Uh, well, it's for sale. I can email it out. Yeah, we're good. All right, so what am I doing? Share, view, send a copy. I can send a copy to YouTube? What does that mean?
Do it.
Just play the slideshow.
It's pretty slick.
Send a movie to YouTube. Next. Why would anybody go to YouTube and just watch a slideshow? That doesn't seem right. Yeah. Copy link. So secure, you only had to guess the username. Do I not know my username? Or is it storing the wrong password? Storing the wrong password.
So they just keep on guessing different usernames because they think the password's already there.
That's right. It's all part of the security. It's network security right there. In a nutshell. Quick message. Slides. All right. You should now have the slide, a link to the slides. Technically, now you should have a link to the slides. Okay. So let's go through, and I'll kind of point out the things that I think are going to be important and might make an appearance on the exam. When is our exam in here?
Friday at 1.
Friday at 1, okay. We have 2 hours to take the exam. I will design it to take a minimum of 4 hours. So usually I design finals to take about an hour. You have the full 2 hours to take it, but I'm not attempting to fill 2 hours with exam. So it shouldn't be a time constraint type thing. So expect that there will be people leaving substantially before 2 hours, but you have the full time if you'd like it. All right, so I'm going to kind of go through the same process that I'll do before I write the exam. I'll write it probably Friday morning. So as I'm flipping through these slides, I'll kind of yell out when I see something I think might be kind of important. So then that's kind of depending on my mood on Friday, which things actually make the exam. But if I tell you something's not really that important now, chances are I'm not going to find it important on Friday. Okay, so I might say there's 60 things that are important, and I'm only going to pick from 20 of them, but I guess we'll see. We'll see what I decide is important. And then any filler I need is just going to be all programming. Well, I mean, certainly organization of the internet, like how the internet works in terms of regional ISPs, global ISPs, DNS, local networks, NATs, network address translations, all that jazz. Just kind of the whole Internet of Things type stuff. Nothing about internet appliances. Those are stupid. Concept of protocols in general. What is a protocol? Why do we need them? That type of thing. Maybe some specifics as it relates to like the HTTP protocol from the perspective of what's it originally for, and then how it's being leveraged modernly for RESTful APIs. Let's see. That's kind of protocol-y crap. Protocol-y crap. Kind of the concept of a firewall as it relates to like a router, a network edge, that type of thing, where we kind of have, and this kind of goes back to this idea of the internet, where we have a local network, and then that's part of a larger network, which is then part of a larger network, and we have what they call network edges, which are the dude that separates, for instance, the network edge here on campus is the our main, what's called edge router, that separates us from the rest of the internet. Okay, so we have one point of failure, and the internet comes and takes us over, and we turn into, I don't know if it's zombies or cyborgs this month, it switches. But in any case, so the conceptual organization of the internet and how routers play into that. Let's see. Different types of internet connections, DSL, cable, kind of pros and cons of each. Certainly be able to give me some information about bandwidth. Like, what does it mean for internet to be good? Why do I have to keep doing that? Somebody keeps sitting in my seat and dropping these down. Somebody's been in my chair. That's so much better. What was I talking about? Oh, yeah, so if I asked a question along the lines of what makes internet good, you know, it's not just download speed. There's all sorts of other things that play into it. Latency. If I tell you that there's you know, you have 50 megabit per second download speed for your internet, how fast is that actually? Maybe I might give you an example. Let's say that you have a file of this size. What is theoretically the fastest you could download that file? Something like that. All right, so understand that kind of stuff. Synchronous versus asynchronous internet connections. Is this a word? Cable head end? See that one? I don't think that's a word. Head end.
I forgot a slash.
Head/end?
Yeah.
Could be. Oh, I like this question. Why did early cable modems require a dial-up modem to function properly? That could make an appearance. Certainly the idea of resolutions as it relates to data traveling over a network. So not something like, you know, what's the number of pixels on a certain size monitor or something, but more along the lines of assuming you have this resolution and video that is being streamed at 24 frames per second, how much data per hour must your internet connection be able to handle, or something like that. Let's see. Kind of the same crap. The concept of packets. So dividing our data up into smaller pieces so that we can do store and send and that kind of stuff. So we don't have to resend the entire piece of information over the network. So kind of the start of TCP/IP stuff, I guess. Waste. Store and forward, important. How essentially our data propagates over the internet. and we only have to take one step back in the event of a data failure. There's a lot of extra work, overhead associated with data being sent over the internet, but at the cost of protecting us from having to resend everything. Probably won't ask a question about queuing delay stuff. I probably won't ask anything about circuit switching, just know it exists, I guess. I won't ask anything about it. It's stupid. Frequency division versus time division multiplexing, certainly important. I probably wouldn't ask a question like, what's the difference? I might ask a question, like give you a scenario and say which would be appropriate for this FDM or TDM and why, something like that. Or I might say, give you a scenario and say it uses TDM and ask you to explain why it, you know, what advantage TDM has for that over FDM, something like that. But I doubt very much I'd ask you a straight question like, tell me the difference between these. And more than likely, I'd give you a scenario that's just so confusing to read, it's not even funny. And then you bring it up to me during, especially the Portuguese guys. So, I'm gonna write that question in Portuguese. I'm gonna need your assistance. Because I'm gonna probably ship it into Google Translate. It's gonna give me garbage. These guys just be sitting there chuckling. He's talking about feeding a cat here. All right. All we care about is packet switching stuff. Packet switching networks is our world today. Circuit switching it's old stuff. Still exists. I won't ask you anything about circuit switching though. Yeah, here's the whole network of networks thing for internet. So anything internet related is fair game. Did we?
Yeah, wait. Go back. There.
Oh yeah. What's this? Are these like harnesses?
I don't think we ever got that detail.
It's really good.
No, Google was the head of the centipede.
Oh, this is the head of the centipede?
Yeah, that's all we determined.
And then these guys were so insignificant, we just called them tears. I suppose there could be a human centipede content question.
I'll look for it.
Describe the meaning of this quote. You can be the middle. Let's see. Probably the big ISP stuff as it relates to DNS. So really more DNS. How does the domain name system work? Domain name service work? Old Alex actually had a recent experience with DNS problems, right? Yeah, he was having some issues with his wireless. Couldn't get anything to work here on campus, and part of it was because, for whatever reason, I don't know why this is, but his when it got the IP address for his machine, it was usually DHCP protocol hands out DNS servers I want you to look for and things like that, and he was getting like fake DNS servers. Well, the DNS servers, like for instance, the guy here on campus where you say, I would like google.com, what's the real IP address of that? And our DNS server here on campus would likely know what Google's IP address is, and it would do the work. Well, he was sending it to, I don't know, Cheesecake Factory or something, and not able to connect to anything. There was a couple of sites that worked, just randomly, right? But they were probably cached, is my guess, in your browser. But kind of how does DNS work in terms of that layered approach where we check locally, then keep passing the buck, passing the buck, passing the buck till we get to the top level. And if they don't know it, nobody knows it. Okay? Let's see. I'm not going to ask you anything about packet delay. Queuing delay, no, stupid. That was more midtermy when it was fresh in our mind. Packet loss, throughput. You should certainly know everything about airlines. Ticketing, baggage, gates. No, this is... I would say this is the next important thing, the IP stack. So this concept of application, transport, network, link, and physical, you know, how these guys all work together. It sounds more complex than it is. This is just a function, a function, a function, a function, and these functions pass things to each other. Okay, so we've compartmentalized the different things. So, for example, I could give you a scenario and ask you at which level in the IP stack does this occur? Something like that. Again, that would likely be in Portuguese. Oh, actually, we should go Vietnamese. Right, old Alex? You speak Vietnamese, right? Yeah, so you can help me out with that?
Sure.
Sweet. And then we go Arabic.
Why not?
Man, Arabic's got crazy looking characters. It's just like art. Why is it so different?
Why is it so different?
Yeah, because it really looks like art, doesn't it?
You're writing from the right to the left rather than left to right. So.
Well, but like, so, you know, I don't speak Hebrew, but being Jewish, I had to like learn all this garbage. And they go right to left too, but it's not.
All the letters connect.
Yeah.
That's why I kind of look like.
So it's like cursive, but that's your default.
Yeah.
Yeah. See, I can't do cursive. I print. That's because my second grade teacher messed me up. She taught me how to hold the pencil. You know how a lot of lefties, you see them, they hold like the pencil like this, or they like wrap their wrist around. Who's left-handed in here? Just me?
Yeah.
Watch a left-handed person write. If they were taught, quote, correctly, they'll hook their arm and they'll be writing kind of the other way. That way the pencil is leaning the right way because your stuff's supposed to lean to the right. They taught us how to hold the pencil as a right-hander, didn't know I was left-handed, so everything was leaning this way, and I just kept giving me crappy grades. So I almost failed second grade between that and neatness of desk. True story. That was back, remember the desks, did you have the desks that open like the top? Did you have those when you were in elementary school? My desk didn't even close. It's like a constant slope. All right, let's see. I won't ask anything about the OSI thing. I only care about TCP/IP. So that extra, the OSI 7-layer model, nobody talks about that. TCP/IP 1, it's just the 7 things compressed into 5. These are the 5. All right. Stupid. Certainly, you know, maybe denial. How does a denial of service attack or a DDoS, distributed denial of service attack, work? Like, why is it? How does it bring down? How does it hurt a network? that type of thing.
Why did every slide say bad guys?
Bad guys, bad guys.
Because this is network security. You got the bad guys. The bad guys are trying to break into your network, right? What should it say instead?
If they had more pictures, this could be a children's book.
It's true. Yeah, I don't care about malware. That's stupid. But DOS and DDoS, two very different things. DOS comes from a denial of service attack is specific to overwhelming a machine. Okay, but you're stuck with how that. A lot of times you have to have physical access to the machine, so it could be running a piece of software directly on the computer that takes it over. For instance, I know you'll enjoy this, Abe, creating a program that infinitely forks. That would certainly take up system resources quick. All right. Distributed DDoS, distributed denial of service, typically is an external attack from a whole bunch of different sources. Because what ends up happening is most of our network security protocols today, like for instance, let's just say I take this one computer here and I write a Java program that just infinite loop just keeps sending a request to google.com. They're going to block my IP after a minute or something, probably less than that, but whatever. You know, they're going to have some sort of protocol in place to block, to keep me from doing what I'm doing from one machine. So I'm a fly on the wall nuisance. Well, if somebody writes a virus or something like that that propagates the internet and seemingly doesn't do much, well, all of a sudden now you have a zillion computers around the world all attacking Google. And what are they supposed to do? Block everybody? And those people they're not even aware they're doing it. Kind of a similar attack to this. It was kind of similar, but I guess dissimilar, was the Bitcoin mining virus, where some people wrote a virus that just propagated across the entire internet, was installed on millions of computers, and they were using that computer CPU to mine Bitcoins, all under a single address. Nobody knew, just their CPU was working a lot harder than it was supposed to be, and their power bills were going up, and all this stuff, and all the Bitcoins are going into somebody else's account, and CPU mining for Bitcoins is horrifically inefficient, but it was on somebody else's dime. It's on their power bill. You can get, if you have the latest, greatest CPU today, it cannot mine Bitcoins. It probably mines Bitcoins at 2% the speed of a crappy graphics card. And graphics cards mine Bitcoins at 1% the speed of a dedicated Bitcoin mining circuit. So CPUs are a horrifically inefficient way of mining Bitcoins. But you get a million CPUs, you might get some Bitcoins. It's kind of the punchline.
Obviously, we know about it. How did they figure out what was going on?
Well, I think what you end up having is a lot of people having high power bills, and there was some. I think it was during the the crackdown with the underground Bitcoin thing, where they were selling organs, where there was all these Bitcoins were being paid to a single address, but so they took a look at the blockchain, and all these Bitcoins were being paid to a single address from like a zillion different sources. So it certainly seemed like it was unlikely this person was going to have that many nodes mining Bitcoins. So they investigated it, and it turned out that the sources they were coming from, these people weren't aware of it. And then once they figured out, a couple of people figured out something was wrong, then the virus rating people started blocking the port where it was coming from. And once they saw that was working, then they came up with a removal tool. All right, so packet sniffing, the idea of listening on a network, because networks are broadcast-based, and taking a look at the packets that are flowing over the network and trying to glean information from it. And this kind of goes hand in hand with encrypting network connectivity. reading information about a packet is garbled anyways, but not unreadable. They could piece information together by just looking at a packet. You encrypt it, it becomes a lot more difficult. But the point is that, just like in here, we have a wireless network going. Nothing keeps us from sitting there and just sampling all the packets that are flowing through the wireless network and then opening each one up and seeing what we see. Maybe getting passwords, maybe getting parts of passwords, maybe seeing who's surfing what sites, stuff like that. Let's see. Fake addresses, yeah, it's called IP spoofing. The idea would be this dude here would pretend like he's this dude here and make a request to A. So let's say this computer has authenticated with this server, and this guy has been sniffing those packets and knows what he's doing. Now he can pretend he's B by replaying some message this guy had sent, and now he has access to this server as well. Stuff like that. I don't know if I'll ask you anything about IP spoofing, but it's certainly fair game. I'd have to run out of other questions. I'm certainly interested in this, but it wouldn't be high up on my my list. All right, so then we started talking about client-server stuff. So really client-server in general. Kind of talking about the primitives for network communication in terms of sending bytes over a network. Converting numbers, I almost always put some sort of number conversion thing in there. So that should be easy points, but be able to convert if I tell you to convert some number in octal to binary, you should be able to do it. So even if you have to take it to decimal first, then decimal to binary, whatever, you should be able to do the math conversion stuff. I tend to like those kinds of questions. I would expect there to be, I would say, a minimum of 2 mathy type conversion questions like that.
You're going to put another 46-digit binary number on there again?
Maybe. What was that one? Was that this? That wasn't this class. Wasn't that architecture?
I think that was this class you did that.
It wasn't this class.
What was the question?
Is that last semester?
It was last semester.
Oh, yeah, you did like a 44.
Yeah, but that was an easy question, wasn't it?
Well, yeah, it was just annoying because it was that many digits, but
I know, that's why I put it on there. Wait till you get your Portuguese paint by number on this this one. We're gonna have all sorts of. Going to be all inclusive. We're going to have a Vietnamese question. We're going to have a Portuguese question.
you have to incorporate that into the Brazilian question. Lista linkada.
Lista linkada. That's true. Actually, in Portuguese, don't you do the question mark, the upside down question mark beforehand and after?
No, this is just.
That's just Spanish?
Yeah.
So Portuguese is a more evolved language. I never understood that. It's like, let's just put the punctuation at the beginning and the end, and let's make this one upside down. That seems like somebody who's had too much tequila.
that way they know it's going to be a question to the entire.
That's right.
Oh, hey, this one's going to be a question.
There might be some logic to that, actually. You don't have to wait till the end. You know it's a question to start. They might not have been as drunk as we think. Okay, so we talked a little bit about kind of the BitTorrent network and how that works. So kind of this distributed system for sharing things. So originally our client-server model where we have a single server and everybody's pulling data from that same server. And that means that all of these individual clients are sharing resources from the single server. Not just bandwidth resources, but also CPU resources, memory resources, all that jazz. So kind of the advantage of having a distributed type network where all the different network nodes are doing some of the work. Okay, so then we talked about some of the modern technologies for client-server stuff. So really, from a computer science perspective, when we think about client-server, we think about client-side being our web browser to start with. We think about server-side being a web server to start with. And originally, it was just the server serving web pages to the web browsers. But then that pretty much, that kind of evolved into APIs for talking to a whole bunch of different data sites where, or data stores where our clients were changing. It wasn't just a web browser, now it's a mobile phone. It could be a standalone application, whatever. We have all sorts of different clients now that talk to web services. And web services are now supported with fairly complex web languages, or complex programming languages, PHP kind of being our mainstay now, been around for a long time. And then we talked about some of the newer technologies. So problem with PHP. So I might ask a question dealing with what are some negatives of being a PHP developer or writing an application in PHP or something like that, dealing with having to have a development environment set up and having to FTP your files up, having those things someplace else. Then our newer technologies, Ruby and Python, and, well, specifically Flask for Python, and then Node.js kind of fix some of that by giving us an instantaneous development environment. Okay. Well, this is when we were talking about the kind of the evolution of APIs. So how we got to kind of RESTful API type stuff. So that's where this guy comes in. So we had our proprietary APIs. Then we moved to a standard called SOAP, but not all SOAP standards were created equally. Then we decided let's go ahead and base all our modern APIs on the HTTP protocol that's 1,000 years old. And that's kind of the concept of a RESTful API. So certainly understand RESTful APIs and be able to tell me about them, specifically CRUD. Abe, able to tell me about CRUD as it relates to RESTful APIs. The concept of asynchronous communication and the advantage of that, kind of what did Node bring to the table? Almost that comparison between threads being, well, multiple processes being the old school way of doing it, threads being the replacement. Now, what's the weakness of threads? So I might ask a question like, what's the weakness of threads as it relates to the client-server model where there's many clients connected simultaneously? Something like that. So be able to tell me some of the problems of threads, and then how asynchronous communication attempts to fix that. I won't ask you anything about unit testing. That probably just came up at some point. Certainly the concept of streams, input-output streams, the idea of half duplex versus full duplex. And then I'd be interested in hearing Abe's take on the pipe. So kind of what...
Is that a question only for Abe?
That'll be the Abe version of the question, and everybody else is going to get the Vietnamese.
Don't get too excited. Yeah, Columbia's good.
Yeah. We actually had a very interesting... You guys remember Blade from the hackathon?
Yeah.
How many of you don't know who Blade is? I'm guessing most of you. Only the people at the hackathon should know who Blade is. It's a Chinese grad student here. His name's Yiming Liao. Yiming Liao. Liao, yeah, something like that. So we just called him Blade. So we were talking about various weapons, and he said that we were talking about like the weapon of choice for different cultures. And I guess Chinese is it's large blade. So Blade, right? Well, so I don't know. What were we talking about the other day when Blade said no? They used the pipe. Remember that breakfast? I think I was talking about him like burning herbs or something like that and putting it in.
Yeah.
And he says, no, he still used pipe. I love Blade. That guy's awesome.
Something about drugs.
Huh?
Something about drugs.
Yeah, we were talking about like the Chinese herbal medicines and stuff like that, except Blade's into some other stuff.
It was also the same conversation we got pebbles from.
That's true. Okay, yeah, so duplex, full duplex versus half duplex, so directional flow of data over streams. Specific to node, readable versus writable streams, kind of what they're for. Okay, so this is kind of a picture version of that whole how does asynchronous communication somehow solve the thread problem that we referred to. I might ask you how the event loop works in Node, what its purpose is. Let's see. I will not ask you to write any code. Not a programming class. I potentially might ask you to read code. I would say there's not a high probability of that, but if I'm running low on questions and I want to give you some sort of example and to ask you to tell me what this does, it would probably be a Node example since that's relatively fresh, but I won't ask you to write anything. Reading only. All right. Any questions? All right, Friday at 1 p.m. you said? All right, I'll probably be here. What's up?
My last semester.
Yeah, you weren't there for either last semester.
Really?
Oh yeah, that's because you were in Pennsylvania.
Oh, it wasn't the midterm?
Yeah.
That was just this past midterm.
This past? No, this wasn't this past midterm.
Oh, you're right.
That was
It's been
last semester.
man, it's been that long
That was
since
the
my
finals too.
yeah. Well, your grandpa only kicks the bucket sometimes. So, I mean, you can't skip that funeral. I mean, it was like a sixth uncle or something like that. This was a Jewish guy that visited every Christmas. That's dedication. All right. So I'll see everybody next Friday. If you have any questions, feel free to ask. I encourage you to get on Slack and maybe get a study group or something like that to talk about some of the garbage. And I'll see you when I see you. Yeah, garbage, crud.
Really? Yeah.